Hello friends, I welcome you all in my series of lectures on radar engineering. So today we are going to see about MTI radar. So there are three types of the MTI radar we are going to see today. That is radar MTI radar with a power amplifier transmitter, MTI radar with a power oscillator transmitter, or we are going to see the non-coherent MTI radar. So one by one we will see all these three types of the MTI radar. So first of all, MTI radar with a power amplifier transmitter. So when we're talking about the MTI radar with a power amplifier transmitter, you can see it consists of a power amplifier, then the pulse modulator. Now this power amplifier is getting the input signal from the two basic oscillators. One is called as a stello and coho. Stello generates the frequency FL, coho generates the frequency FC. What are the significance of this stello and coho, how they are working? That we'll see later on. When this FC and FL, these frequencies are given to the mixer will add these two frequency signals FL and FC, and that gives to the power amplifier. Now this power amplifier will amplify the signal as well as amplifier is turned on and off to generate the pulses out of it. So the pulse modulator is used, and then this FL and FC signal is given to the antenna to the deflector for the transmission. Now as it works on this Doppler effect, then when this transmitted signal is intercepted by the target, then the frequency of this back reflected signal is change. Like you're getting the back reflected signal as FL plus FC plus or minus FD. So this signal is given to the mixer. So first mixer. So in the first mixer, the another reference signal is a stello, that is FL frequency. Mixer will subtract both. Remaining is the FC plus or minus FD. So that is given to the IF amplifier. IF amplifier phase and the coherent oscillator phase signals are equal. The phase of the signals are equal, and then this is given to the phase detector, that is FC frequency, coherent oscillator frequency, as well as IF amplifier signal. Both are given to the phase detector. So whatever the difference in the phase that is founded out, that is FD, and that is given to the delay line. This is an actual basic block diagram for this MTA radar. We will see in detail. A transmitter which consists of a stable low power oscillator followed by the power amplifier is sometimes called as a MOPA, which stands for Master Oscillator Power Amplifier. So here power amplifier and the oscillator is there in the transmitter. Here the coherent reference signal is supplied by the coho, that is coherent oscillator. The coho is a stable oscillator whose frequency is same as the IF frequency of the receiver. The coho, that is FC, coho frequency, that is FC, also mixed with a stello. What is stello? Stello is a stabilized oscillator generating the frequency FL. The RF echo is heterodyne with the FL to produce the IF. So after amplification and the IF, the received signal is phase detected with the FC. So as I explained you, that is initially the FC and FL are added and given to the power amplifier, and the pulses of these frequencies are transmitted. Then that will be interrupted by the target, and target will back reflect the signal. So back reflector signal consists of three frequencies: FC, FL, and the Doppler effect frequency FD. So these signals are given to the receiver, and at the receiver first mixer will come in picture, and that will mix the stabilized oscillator signal FL signal with the RF echo signal. So that will subtract the FL signal, and the resultant signal is produced, and that is called as the IF signal. So IF signal is amplified And after amplification at the IF, the received signal is phase detected with the FC. That is, received signal is compared on the basis of a phase with the coherent oscillator signal FC. The Here we have to note down like that the heterodyne process is used to avoid the inverse frequency noise, that is 1 by f noise, to give the video proportional to the phase difference between the two signals. The characteristic feature of this coherent Mti radar is that the transmitted signal must be coherent in phase with the reference signal and the received signal. The phase of the coho is then related to the phase of a transmitted pulse and can be used as a reference for the echoes from that particular transmitted pulse. So now coherent signal phase and the echo signal phase is compared. Upon the next transmitted pulse, the another IF locking pulse relocks the phase of the CW coho. The reference signal from the coho and the IF echo signal are both fed into the mixer called the phase detector. The phase detector differs from the normal amplitude detector since its output is proportional to the phase difference between the two input signals. Any one of the transmitting tubes like triode, tetrode, klystron, traveling wave tube, and the crossfield amplifiers might be used as a power amplifier in this device. So this completes Mti radar with a power amplifier. Now we will move to the next type of Mti radar, that is Mti radar with a power oscillator transmitter. So here we can see the magnetron oscillator is used. Then the magnetron oscillator is controlled by the pulse modulator and the pulse modulator is controlled by the trigger generator. And whatever the signal generated by this magnetron, that can be used as an RF locking pulse given to the mixer in the receiver as a reference signal, and the transmitter section signal, that is a magnetron oscillator signal, that is pulse signal, that is given to the antenna through the duplexer. So when this signal is transmitted towards the target will back reflect the echo signal, but while reflecting that, it will change the frequency and the oscillation of frequency and the phase of this echo signal, that is indicated as a FD, and then this change frequency signal is compared in the mixer along with the spallover, that is a stabilized oscillator. Then the resultant signal which is generated, that is IF amplifier, IF signal, that is given to the phase detector, same as that of Mti radar with a power amplifier transmitted, and then the phase of the IF signal and the coherent signal is compared, and whatever the phase difference, based upon that we have to find out the velocity of the target. So now we will see this operation in detail. Before the development of the klystron amplifier, the only high power transmitter tube available at a micro frequency for radar applications was the magnetron. In the magnetron oscillator, the phase of the RF bears no relationship from pulse to pulse. So for this reason, a reference signal cannot be generated by a continuously running oscillator, otherwise it will become a CW radar. So block diagram of a Mti radar with a power oscillator is shown in figure 4.6 that we have seen. The portion of a transmitted signal is mixed with the shallow, that is stabilized oscillator output, to produce the IF beat signal, whose phase is directly related to the phase of the transmitter. This IF pulse is applied to the coho, that is the coherent oscillator, and causes the phase of the coherent oscillator to lock in steps with the phase of the IF reference pulse. The phase of the coho is then related to the phase of the transmitted pulse. So initially, magnetron generates a signal that is given as a reference signal, but the phase that is reference signal is mixed with the shallow, that is stabilized oscillator, so that the phase of the signal should be constant, and that constant phase signal is given as a reference signal to the current oscillator. So the phase of the current oscillator is a log,